Unit P, Objective 1, Exponent Notes. Level 1, Review Discussion, working with exponential expressions. What does it mean to square a number? Is 4 squared equal to 4 times 2 or 4 times 4? When we square a number, it means to multiply the number by itself. So 4 squared is equal to 4 times 4. In the expression 4 squared, the base of the expression is the number 4. The exponent is the number 2. So we would say that expression as 4 to the second power, or 4 squared. And how many times do we use the base as a factor? 2 times, because as we set up here, 4 squared indicates 4 times 4. So we are using the base 2 times, and each of those numbers are considered factors. To factor means to write as a product. Level 2, Basic, Rewriting Exponential Expressions. In the expansion, 2 times 2 times 2 times c times d times d times d, how many times is 2 used as a factor? So we see the 2 is written 3 times. And so we would say that 2 is used as a factor 3 times. C is used as a factor 2 times, and D is used as a factor 3 times. So if we were to translate that expression into one that contained exponents, it would be written as 2 to the third, because the base 2 was used 3 times, times c to the second times d to the third. You could also write it as 2 cubed c squared d squared, or d cubed. Rewrite each expression by expanding to remove the exponents. So 5 to the third power would be rewritten as 5 times 5 times 5, because the base is used 3 times with the indication of the 3 in the exponent. Y to the fourth would be written as y times y times y times y. Use the expression 2 squared times 2 cubed to answer the questions. Rewrite the expression and determine how many 2's are in the expansion. So if we expand that, so going from exponent notation to expansion, we would write that as 2 multiplied by 2 multiplied by 3 more 2's. And so we would see that altogether we have 5 2's in that expansion. So that becomes 2 to the fifth. Determine a shortcut to rewrite the product as a single base of 2 raised to a power. So what would be the shortcut if 2 to the second times 2 to the third resulted in 2 to the fifth? The shortcut would be that we would take those 2 exponents and we would add them. And so 2 to the fifth is 2 to the 2 plus 3. And that is the shortcut for multiplying when you have the same bases on your exponent expression. You add the exponents. Rewrite the expressions to remove the exponents. So 4x to the third, if we're going to remove the exponents, the 4 in front of the x cubes always indicates multiplication. That 4 is called the coefficient of the term. So this is 4 multiplied by x, and that x is going to be used as a base 3 times because of the exponent of 3. In number 8, we have the quantity. So we call that the quantity because of the parentheses around it. The quantity 4x raised to the third power. That would be written as 4x times 4x times 4x. So that 4x is the base that is used 3 times, or the factor that is used 3 times. How many 4's are there in the first expansion in number 7? Okay, so there's 1 4 there. How many 4's are in number 8's expansion? There are 3. Why is there a difference? Well, there's a difference because parentheses are used in number 8. So because the 4 is included in the parentheses in number 8, then it is used as a factor 3 times because that exponent of 3 is applied to the 4 and it's applied to the x. Number 10, rewrite -5 squared by removing the power. So that negative in front of the 5 squared indicates multiplication. So that is -1 multiplied by 5 times 5. So -1 times 5 times 5. So that 2 is the exponent applied to the 5 with a -1 multiplied by that. Number 11, -5 is used as the base twice. So that is -5 times -5. So visually, you can see that the two look different. In number 12, it says, are your values to number 10 and number 11 different? So if you multiply number 10, you get a -1 times 5, which is a -5, multiplied by 5 is a -25, versus -5 times -5, which is a +25. And again, why are the two answers different? Well, first of all, visually, number 10 and number 11 look different. But the reason that the products result in a positive versus a negative are parentheses. So again, it is really important that you pay attention to where the parentheses are and what base is included inside the parentheses. Number 13, evaluate the following and label them on the number line. So for each of those, I want you to take a moment and calculate what those are using your calculator. So in A, that would be -1 times 4 times 4 over a -2 times -2. And you can utilize your calculator to help you, or you can try to do some mental math and see if you can figure it out without your calculator. So the numerator there would be -16. The denominator would be 4, and -16 divided by 4 is a -4. And so we would put a dot there, and we would indicate that that is the location of A. In B, we have -2 raised to the third times 5, but that is not the quantity -2, so we're not using -2 as the base. That is -1 multiplied by 2 3 times, multiplied by 5 over 2 times 2. In the numerator, that's going to be -40, and in the denominator, it's going to be a +4, and that gives you a -10. So down here at -10, I'm going to put B. C, because of the parentheses around -4, we are using -4 as a base twice. So that's -4 times -4 divided by -2. So that's going to be 16 divided by -2, which is -8. That's going to be our C. And then D, there might be some notation there that you are not familiar with or you don't remember, and those bars indicate absolute value. So inside, that's going to be -2 times -2 times -2. So we're using -2 as a base 3 times. That's going to give me the absolute value of -8. Absolute value means that you take the opposite of -8, or you make the answer positive, and then that's going to be 8. So over here at 8, we're going to put D. And that is the review before we jump into the rules of exponents, and that is our level 3 focus. So for our first example, we have 3 to the 5 and 3 to the 6. So if you remember from the earlier examples, if we were to expand that, that would be a lot of 3s. So that would be 5 of them written out, 1, 2, 3, 4, 5, and then 6 of them, 1, 2, 3, 4, 5, 6. As I said, that's a lot of 3s. And if you count them all up, that's actually 11. So that's 3 to the 11th. And so that shortcut, as we discussed earlier, would be to add those exponents. So that would be 3 to the 5 plus 6, which gives you that 3 to the 11th. And so it's nice to know the shortcut for this rule. And that shortcut is your product of powers. So if you have x raised to the a power times x raised to the b power, your shortcut is going to be to add those exponents. And so x squared times x to the 7th is going to be x to the 2 plus 5, which is x to the 7th. I think I said 7. So x to the 2 times x to the 5 is x to the 7th. So that is our first rule or shortcut. Second shortcut. We have 6 to the 7th in parentheses raised to the 4th. So if we follow what we discussed earlier, that would mean that we would write 6 to the 7th 4 times. So we would use that as a base 4 times. And then if we follow the previous example, we would expand and we would write that 6 as a factor 7 times, and then 7 times, and then 7 times, and then 7 times, which we're obviously not going to do. And so our shortcut would then be to add those all up, and that would be 6 to the 28th power, because 7 plus 7 plus 7 plus 7 is 28. So if we look back at the 7 and the 4, a shortcut would be to multiply those powers, or multiply the exponents 7 and 4. And if you multiply 7 and 4, you get 28. So x raised to the a raised to the b power, our shortcut is x to the ab. And so x to the 4th to the 5th, why don't you go ahead and try that using the shortcut and then check your answer. And that gives us x to the 20th because we're going to multiply those. The next shortcut is called a product raised to a power. And so 4 times 5 to the 3rd. If we were to expand that, that would mean that this would be used as a factor 3 times. So that would be 4 times 5 times 4 times 5 times 4 times 5. And as you can see, there are 3 4s here. 4 times 5, sorry about that. And there are 3 5s here, which would indicate that that exponent of 3 is going to get applied to each of those factors, the 4 and the 5. And so that would be 4 cubed times 5 cubed. And so the shortcut, instead of expanding, and so a lot of these shortcuts are ways to have you not write out the expansion in order to produce the answer. So our shortcut would be x times y raised to the a power. So in other words, 2 different numbers inside there, the 4 and the 5, is a shortcut of x to the a times y to the a. So I'll let you go ahead and try that next example, and then you can check your answers with mine. Moving on to dividing shortcuts. So if we look at the first one, we have x to the 5th over x squared. So again, if we always go back to our expansion, 1, 2, 3, 4, 5 x's over 2 x's. Now, if we remember something about fractions, we know that anytime we divide a number by itself, it's equivalent to 1. So that x divided by x is 1. So they will divide away. The next x divided by x is also 1, leaving you with 3 x's. And so the answer to this is x to the 3rd. So now if you go back and you look at those exponents, you see that if you were to subtract 5 and 2, you would result in 3. And so the dividing powers rule says x to the a divided by x to the b, the shortcut is x to the a subtract b. So when you're dividing with exponents, you subtract them with the same base. I want to stress that we have the same base in this expression. Okay, I'll pause for a minute and I'll let you try to do the next one using the shortcut. So for the next one, if you subtract, you get 5 minus 3 is 2. 4 minus 6 is negative 2. So this leaves us with an expression that has a negative exponent. And the general standard rule is to not leave answers with a negative exponent. So let's think about this as if we were to expand it. So a times a times a times a times a times b times b times b times b all over a times a times a, and then 6 b's. So if we use this idea that any number divided by itself is 1, that's an equivalent of 1, that's an equivalent of 1, that's an equivalent of 1. So we're allowed to divide away those a's. And then we can divide away common b's. So b, 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 b. We actually see that those 2 b's are in the denominator of the answer. And so that b to the negative 2, in order to make the exponent not negative, we move it to the denominator because we see that that's actually where those b's are when we expand. So the correct way to answer that would be a squared over b squared. So we should have a rule for this so we know what to do when we have negative exponents. So the negative exponent rule says you follow whatever previous rule you're using. So in this case, w to the 2 over w to the 6, that would be our subtraction rule. So that would be w to the 2 subtract 6, which would give me w to the negative 4, which we would rewrite as 1 over w to the positive 4. So for the negative exponent rule, it is simply x to the negative a is equal to 1 over x to the positive a. And if it's 1 over x to the negative a, that is simply x to the positive a. The next rule is the 0 powers rule. So again, we're going to go back to our expansion because something you should remember is if you ever forget the rules, you can always go back and expand your exponential expressions to come up with the right answer. So x to the second power is going to be used as the base 3 times. So that's going to be x squared times x squared times x squared over x to the 6. Now we remember you add those, and so that's going to be x to the 6 over x to the 6. And we could have used our power to the power rule also. You will find when you're working with exponential expressions that sometimes you can use one rule or another rule, and both will lead you to the correct result. So now we have x to the 6 over x to the 6, which if you have the same number or expression over itself is 1. Now if we go back and use our subtraction rule, we would see that x to the 6 over x to the 6 is really x to the 0. Because if you take 6, subtract 6, you get 0. And so by definition, x to the 0 is 1. Any expression raised to the 0 power is 1. So x to the 0 is 1, y to the 0 is 1, z to the 0 is 1. Any expression, any base raised to the 0 power is 1. So 12 to the 0 is 1. And that comes from having the same term over itself is equivalent to 1. And so if you're going to have the same term over itself, you're going to have the same exponents. And if you subtract those, you're going to get 0. And so x to the 0 is going to result in 1. All right, quotient of powers rule. So let's start combining some rules here. So c squared over d. So if we remember back to the power raised to the power, we would know that this is c squared to the third power. We're going to multiply those. That's going to give me c to the 6. Down here we have a 1. So when we don't see an exponent there, we understand it to be 1. 1 times 3 is 3. So that's d to the 3. And that's your answer. So the quotient rule says if you have a fraction raised to a power, you must apply that exponent to both the numerator and denominator of the expression. So if we have x over y to the a, that's going to result in x to the a over y to the a. And if either x or y had exponents, then we would be combining that rule where we would multiply those exponents as we are applying that external power. What happens if our exponents are not whole numbers? The same rules are going to apply. You're just going to have to use your calculator, or you're going to have to fall back on adding and subtracting fractions by getting like denominators. So here we have x to the 2/3 times x to the 4/5. Same base, so our rule would say that it is x raised to the 2/3 plus 4/5. So how do we do that? Well, we have to take 2/3 and we have to add it to 4/5. So 2/3 plus 4/5. If you have your graphing calculator, you can go ahead and type it in. Oh my gosh, what if you don't have your graphing calculator? You have to get a common denominator. So 3 goes into 15 5 times, so that's 2 times 5 is 10. 5 goes into 15 3 times. 3 times 4 is 12. Add those two together, and you would end up with x to the 22 over 15. The same rule applies. So for rational exponent use same rules as integer exponents. So for the next example, what would this look like? Well, this would be a raised to the negative 1/3 raised to the 12. So remember, we have to distribute that 12 to both the base a and its exponent and b and its exponent. Then it would be b raised to the 5/6 raised to the 12. Now we're doing the power to the power rule. So that's going to be a raised to the negative 1/3 times 12. So again, I encourage you to get your calculator out. 12 times negative 1/3 is negative 4. 5/6 times 12, and again, if you don't have your calculator, what the heck's that going to look like? 5/6 times 12 over 1 is going to be 60 over 6, which is 10. So that would be b to the 10. Well, what we see is that we have a negative as one of our exponents. And so we know that we have to simplify our answers so that we don't leave any negative exponents. And so that a to the negative 4 is going to go to the denominator. So b to the 10 over a to the 4. You try, practice. All right, so there's a bunch of problems on here. There's 9 to be, or 12 to be exact. So I'm going to go through and I'm going to pick a couple to do, and then I'll let you try some, and then you can check your answers. So I'll start with number 14. And you see a lot of terms inside there, individual terms, and some of them have the same base. So let's go ahead and combine everything in the parentheses first, and then we'll apply that exponent of 4. So that's going to be 2, and then we have 3 g's, another 1 is 4, and 2 more, 5, 6. So if we remember our rules, same base, add the exponents going across. We have 2 h's, and then another one is 3 h's. And we're raising that to the 4th power. So now remember that this entire term gets raised to the 4th power. So if you were going to expand it, you would write that base 4 times. So that means it's going to be 2 to the 4th, and then it's going to be g to the 6th raised to the 4th. So our shortcut is to multiply. That's 24. H to the 3rd to the 4th is h to the 12th. And you can leave your answer like that, or you can expand that 2 to the 4th, which is 16 g to the 24th, h to the 12th. Okay, let's try number 17. So I think I'm just going to go down and do these 4, and then I'll circle some other ones for you to try. Number 17, what do we do when we have a fraction multiplied by a fraction? So let's review multiplying of fractions. When you multiply fractions, you multiply across the numerator and across the denominator. So in the numerator, that's going to give us 8, and we don't have any common bases in the numerator, so that's going to be y to the 11th and z to the 7th. It is standard that when you write a term, you write the variables alphabetical. In the denominator, you're going to have 4 y to the 7th, z to the 3rd. Now that they're written as a single fraction, we can go ahead and use our rules of exponents. But first, let's start with the numbers. Because the numbers don't have rules of exponents, the numbers are treated exactly as they are in every fraction. That is an 8 in the numerator, a 4 in the denominator, and we know that bar means divide. So 8 divided by 4 is 2. Now let's go ahead and apply our rule. When it's in a fraction, we subtract the exponents. So that's going to be 11 minus 7, which is 4. Over here, 7 minus 3, which is 4. Okay, we're going to go ahead and try number 20. And as you recall, when the exponents are fractions, we just follow the same rules. So again, there's different ways to start this problem. I'm going to stick with my doing the inside of the parentheses first. And so inside the parentheses, I see an x to the 3rd over x. So if I follow my rules, that's like having a 1 for that. 3 minus 1 is 2. So it's going to be x squared. Y to the 6th, there isn't another y there. And then z, well, I've got a 1 up there and I have a 10 in the bottom. So when I subtract, 1 minus 10 is negative 9. So that's going to be, okay, hold on. I got to erase just that part. That's going to be z to the negative 9 raised to the 1/3. So I did my rules of exponents inside the parentheses first. Now I'm going to apply my power to the power rule. So that's going to be x squared to the 1/3. So I'm multiplying. So it's going to be x to the 2/3. Y to the 6 to the 1/3. So it's 6 multiplied by 1/3, which is 2. And again, if you need your calculator to help you, that's fine. And negative 9 times 1/3 is negative 3. Oops. So z to the negative 3. How do we write our final answer? X to the 2/3, y squared, and then we remember that we push that negative exponent to the denominator. All right. Last example is going to be over here with number 24. So again, actually, yeah, I'll do number 24. Again, I'm going to do what's inside the parentheses first, and then I'll apply that outside exponent of 4. So we have 3, no other numbers there, so we're going to stick with the 3. We have an exponent of 1 up there, and 1 subtract 3 is a negative 2, so it's going to be 3a to the negative 2, and then it's b to the 2 over b, so 2 minus 1 is b, and then that's raised to the 4th power. And so I don't have a fraction anymore, or you could have instantly put the negative a to the negative 2 to the denominator. So now we're going to apply our power raised to the power. So the 3 is just a number, so that's 3 to the 4th. So remember, that would mean that 3 would be used as a factor 4 times. Multiplying the exponents here, that's going to give me a to the negative 6, and then b to the 4th. And then we remember no negative exponents in our answer, so 3 to the 4th, b to the 4th, divided by a to the 6th. All right, now I'm going to take a moment to let you try some on your own. So I'm going to have you try number 16, number 19, number 23, and number 25. So you should pause your notes right now, try those 4 questions, and then start them back up again and see if you got them right. Okay, number 19, the answer power to the power would be x to the 10, y to the 5th, and z to the 4th. So you're going to multiply those exponents. Number 16, oops, sorry, I went out of order there. Number 16, you're going to apply that 2 exponent on the second expression first. So that's 2a squared b, 9, because you're using 3 as a base 2 times, a squared b to the 4th. And now you're going to multiply. So 2 times 9 is 18, a squared, a to the 4th, b to the 5th. So we're using our rule where we add our exponents. Number 23, 18 doesn't divide 4 equally. And so all we can do there is divide away common factors. A common factor of 18 and 4 is 2. So that would give me 9 on the top and 2 on the bottom. 6 subtract 3, our exponents on x, is x to the 3. 4 subtract 1 for the y's is 3. And z to the 1 over z to the 1, if you subtract, you get z to the 0, which is 1. You can write your answer like that. You can also pull out that 9 over 2 and write it in front. Okay, number 25, our last one. We're going to expand, so that's 2c to the 4th. That means we're using this as a factor 4 times. And so that would be 2 to the 4th, c to the 4th, negative 3 to the 3rd. I want you to notice how I included that negative 3 in the parentheses, because that indicates that that negative 3 has to be used as a factor 3 times. So negative 3 times negative 3 times negative 3. And so in order to include that, I have to put it in parentheses. C to the 3rd, d to the 3rd, and then times negative 5c. And that negative 5c has an exponent of 1, so we don't need to do anything else with that. Okay, so we're going to have 2 to the 4th times negative 3 to the 3rd times negative 5. So notice how I put all of the numerical parts, the number parts, together. I'm going to look at all my c's. So c to the 4th, c to the 3, and c. So it's going to be 4 and 3 is 7 and 1 is 8. And then d to the 3rd. Now, in order to figure out what 2 to the 4th times negative 3 to the 3rd times negative 5, you're going to want to put that into your calculator. Okay, Okay, so that's going to be 16 times a negative 27 times a negative 5. And so that results in 2,160 c to the 8th d to the 3rd. So you are going to want to have your calculator handy for some of these. If you don't, you're going to have some really big numbers to multiply. Okay, and we're going to go ahead and finish up with a couple more. So number 26, after an oven is turned on, its temperature T is represented by this equation, which involves exponents, which is why it's in this topic. M represents the number of minutes after the oven is turned on, and T represents the temperature of the oven in degrees Fahrenheit. What's the temperature in the oven after it's been turned on for 8 minutes? So we're going to take that 8 minutes, and we're going to substitute it in right there. So that's going to be T equals 400 minus 350 times 3.2 raised to the negative 0.1 times 8 minutes. All right, and so that would mean that we are taking that base and raising it. Okay, so clear my calculator. 3.2, and then we're raising it Okay, so I had to grab my graphing calculator. So that's 400 minus 350 raised to the 3.2, or not raised, but all right, so we have 261.97 degrees. Number 27, the expression is equivalent to, and again, these are just more rules of exponents. So negative 2 is used as a base twice, so that's 4a to the 4th, b to the 6th, 4ab to the 5th, 6a cubed b squared. So we're going to grab our calculators and we're going to multiply 4 times 4 times 6, and that's 96. And if you look, it's multiple choice, so that would take that away and that away and that away, which is nice when you have multiple choice to kind of do process of elimination. We have 4 A's, 5 A's, 6, 7, 8 A's, and so I don't even need to go any further. 28. Rules of exponents on the top here. We're going to add 5, 6, 7, 8, 9, 10. So we have x to the 10 over x to the 10, which that means the same expression over itself, which is 1. If you want to think about the rules of exponents, that would be 10 subtract 10, x to the 0, which we know is defined as 1. Extension. Given the area of a triangle is 108 x squared y to the 4th, with the base equal to that, what is the expression gives the height? All right, so let's do a little recap from your geometry. 1/2 base times height is the area of a triangle. And so if I take this expression and I write it over where the area is, so 108 x squared y to the 4th equals 1/2 times 24xy to the third times the height. And so this is our question. What is the height? Now this is an extension because you're being asked to work with a formula, but it doesn't involve just numbers. It involves exponents and variables. First thing I would do is simplify the 1/2 and the 24. So that's 108 x squared y to the fourth equals 12xy cubed times h. And so in order to solve for h, I'm going to divide both sides by 12xy cubed. Okay, 108 divided by 12. Let's see if it goes in evenly. 108 divided by 12 is 9. X squared over x is x because we're subtracting the exponents. 2 minus 1 is 1. Y to the fourth over y to the third, subtract, and you get y. And there is the answer for your height. So again, it's just practicing rules of exponents, but it's in a more complex question. Number 30. Given the circle graph, if the spinner is spun, what's the probability that it lands on a power of 3? All right, well, probability is defined as number of successes over total number of outcomes. So power of 3. Well, 8, what do we mean by power of 3? So the number 8 can be rewritten as 2 raised to the third power. That's what we mean by a power of 3. So 2 times 2 times 2 is 8, is equivalent to 8. And you can rewrite that with using 2 as the base or 2 as a factor 3 times. Okay, 64. Can we take a number that multiplies by itself 3 times that results in the number 64? So 4 cubed, 4 times 4 times 4. 9 is 3 squared. 6 is 2 times 3. 27 is 3 cubed. And 16 is 2 times 2 is 4 times 2 is 8 times 2 is 16. So that's 2 to the fourth. So if we're looking for powers of 3, I would say 2 to the third because that has an exponent of 3. 3 to the third because that has an exponent of 3. 4 to the third because that has an exponent of 3. So if we go back to probability, probability is number of successes. That's 3 over total number of outcomes. So that's 1, 2, 3, 4, 5, 6. So 3 over 6 or 1/2. All right, our very last extension. So the extensions, if they seem a little more harder, they're just a little more challenging, and there will only be, ever 1 or 2 on a quiz or test. So we're going to simplify using our rules of exponents, okay? So in the top, if I use my rule of exponent, same base, you're supposed to add. Well, one of them is not a number. So what do? Well, you would write that as 2 plus n. So if n were 5, that would be 2 plus 5 or 7. But we don't know what n is, so we're just going to leave it like that. In the denominator, we're going to get x raised to the 3 plus 2n. To finish, we now need to take these exponents and do the last rule, which is to subtract, or the final way to simplify this is to subtract. But when you subtract, it would be 2 plus n subtracts the quantity 3 plus 2n. And the reason that you have to put 3 plus 2n in parentheses is because if you don't, you would only be subtracting the 3 and not the 2n. And you're subtracting this entire exponent. So that becomes 2 plus n minus 3 minus 2n. And if we combine like terms, that's -1 minus n. And so this is x to the -1 minus n. Now, that can be simplified. If you wanted to continue that, you could rewrite that as x to the negative 1 times 1 plus n. And you can leave your answer like that, and we won't take it any farther.